All right. Next thing we're going to do is factoring. A quick one on factoring here. When factoring, a fast way to do it is just focus on our first and last term. If we have a trinomial, so that means 3 terms. Okay. In other words, this is also, it's important that we lay this out. This is in standard form. Okay. We're in standard form, and we're trying to get to factored form. Okay. And standard form is, f at x is equal to ax squared plus bx plus c. Okay, so here would be our c, this is our b value, and this is our a. And so the first step we want to do is find find the factors of a. So the factors of a, or 6, are 1 and 6, and 2 and 3. Okay, and we're going to think of them like they're in columns. All right, so this is a pairing, or this is a pairing. We can't mix the pairings together. We have to work with the pairings. We can't mix them up. We have to work with each pairing together. Then we look for the factors of C. Okay, so we got 1 and 10 and 2 and 5. And then again, the same idea. These are pairings. We can't really split them up. And now that we have these pairings, what we're going to do is we're going to multiply columns. So see how we have them in 4 different columns? We're going to multiply a pair of the first columns by a pair in the second column. And they're going to add up to our B term, which is negative 11 and x, technically. Because technically this is 1x, 6x, and 2x, and 3x. Okay? So we're going to trial and error and jump through this. We're going to try 1 times 1 and 6 times 10. It's going to give me 1 and 60. Is that going to add? Sorry, I didn't write that down, but it needs, these products need to add to negative 11x. Will a 1 and 60 add to that? No. Nope. What if we crossed 1 times 10 and 6 times 1? We get 6 and 10. Will that work? No, that's not going to work. All right, let's jump to the next column. 1 times 2 gives us 2. 6 times 5 gives us 30. Will this pairing work? No. If we go across, 6 times 5 and 6 times 2, that gives us 12 and 5. Does that work? No. So absolutely none in this pairing here worked. So we know that first set of columns won't work. I'm going to try the second set now. Oops. 2x times 1, 3x times 10, that gives us 2x and 30x. Is this one going to work? No. And let's say we go across. 3x times 1, 2x times 10 gives us 3x and 20x. Could that work? Nope. So, let me get rid of this column. Alright, we only got this left, so let's hope that this works, okay? 2x by 2, 3x by 5. That gives us 4x and 15x. Can this work?
Yes, if one's negative.
Ah, good. So that's what we got to recognize. So, what we need to do here, say we do 2x times 2 will give us 4x. 3x times 5 will give us 15x. Which one needs to be negative? 15. And we multiplied 3 times 5 to get 15, so we're going to make the 5 the negative. Okay? We're going to test this out. Multiply this column by itself. What's positive 2 times negative 5?
10.
Just 10?
Negative 10.
Yeah, and that's what we had up here, negative 10. So that's the right set. That one has to be negative because this is a negative here, and we have to be able to build a negative. So now that we have this, that means we're using this column here as our first terms, and this column here as our second terms. Okay, so when we go to put them in our factored form, f at x is equal to, what happens is our first terms, our first terms are the first terms in the brackets, and then our second terms are the second terms in the brackets. Okay, so we're going to fill them in now. I'm just going to put 2x and 3x in. Those are our first terms. Our second terms, the green ones. Now, there is a little trick here. Because we multiplied 3x times negative 5, the 3x and the negative 5 have to go in opposite columns. So I have to put the negative 5 in the, other bracket. And the positive 2 has to go in the opposite of the 2x, so the plus 2 comes in here. So without the highlighted and everything, it kind of looks like this. 2x minus 5, which was what we had, times 3x plus 2. Is that one